Today I'm going to be talking about solving linear systems using substitution. So let's take a look at the first problem. So we have a 3-variable system, and this one is going to be one solution. And when you have one solution with 3 system variables, we're going to solve for an x, a y, and a z. And the solution will be an ordered triple, and you'll see what that looks like. So what we're going to do is we're going to take the first equation and we're going to solve for a variable. So I'm going to isolate the y. I'm going to divide by 3. So I have y equals 2z minus 2. Okay? And what we're going to do with this equation is we're going to substitute it in to the next 2 equations. Never substitute it back into itself. Okay, so let's do the second one. So we're going to have x minus, and our y is 2z minus 2. And make sure you put this in parentheses so you distribute correctly. Plus 4z equals 10. Now we're going to distribute. And simplify. So we have x plus 2z. And we're going to subtract the 2. And we get x plus 2z equals 8. And we're going to stop right there. Once we get those 2 variables isolated, we can stop, and we're going to plug it into the third one. We're going to plug our y into the third one. So we have 2x plus 2y, which is 2z minus 2, minus z, which equals 12. We're going to distribute. And then simplify. So that gives us 2x plus 3z. We're going to add the 4, so we get 16. And we're going to stop right there. So now what we're going to do is we're going to take one of these 2 new equations and we're going to isolate one variable. The easiest one to do that is the red one. So I'm going to isolate x. So I'm going to get x equals negative 2z plus 8. And I'm going to take this new expression and I'm going to plug it in to the green equation. So I'm going to get 2 times negative 2z plus 8 plus 3z equals 16. Now I'm going to distribute. I get negative 4z plus 16 plus 3z equals 16. We're going to combine like terms. We get a negative z equals 0, so we have z equals 0. Once we have this, we can plug this 0 into any equation and get our other variables. So I'm going to go over to this blue one on the left, and I'm going to plug in 0 for z. And I get y equals negative 2. And then I'm going to go over to this equation on the right and plug in 0 for z. And I get x equals 8. And now for my final solution, I'm going to put this in an ordered triple. And I always do it in the form of x, y, then z. So my answer is going to be 8, comma negative 2, comma 0. And that's our system with 3 variables with one solution. Next, I'm going to show you what it looks like to solve a system with no solution. So we're going to do the same as before at the top. Okay, I'm going to solve for z for this one. So I'm going to do this over here. 4x minus y plus z equals 5. I'm going to move everything over away from the z. So I have z equals negative 4x plus y plus 5. So we have our one equation, and we're going to take that equation and we're going to plug that in to the other 2 equations. So let's do the second equation. So we have 8x minus 2y plus 2z, and z is negative 4x plus y plus 5. Now we're going to distribute, then simplify. And now if we notice, the x's cancel out, the y's cancel out, and we get 10 equals 1. Now this is a false statement. 10 does not equal 1. So when we get something like this, when the variables cancel out, this is a no solution. Next up, I'm going to show you an example of when we get many solutions. So first off, we're going to take the first equation. You don't always have to pick the first equation, but I like to. You always can pick an easier one if there is one. So I'm going to solve for y. So I get y equals negative 4x plus z plus 2. And we are going to plug that equation back into the first, or the second and third equations. So we're going to do 4x plus y, which is a negative 4x, so I can write that down, plus z plus 2 plus z equals 2. Okay, and the x's cancel, and we get z plus z, which is 2z, equals 0, so z will equal 0. And that's okay. We're going to now plug in that blue equation into the third equation. So we now have 12x plus 3y, which is a negative 4x, plus z plus 2, minus 3z, which equals 6. Let's distribute, then simplify. 12x minus 12x plus 3z plus 6 minus 3z equals 6. And if you notice, the x's cancel, the z's cancel, and we get 6 equals 6. This is a true statement. So when we do get a true statement, this is infinitely many solutions. So that's what it looks like when we have infinitely many solutions, when we get a true statement and our variables cancel out. Now our very last one is an example of a word problem. Okay, an amphitheater charges $75 for each seat in section A, $55 for each seat in section B, and $30 for each lawn seat. There are 3 times as many seats in section B as in section A. The revenue from selling all 23,000 seats is $870,000. How many seats are in each section of the amphitheater? So when we have something like this, the first thing that we need to do is assign variables. Okay, and I'm going to have x, y, and z. I'm going to assign those as variables. And the x is going to equal the number of seats in section A, the number of seats in section B, and the number of seats on the lawn. And this will help us start to write our equation. Okay, so the first equation I'm going to write is 75x plus 55y plus 30z equals $870,000. Now I did that is because if we plug in the amount of seats, it'll tell us how much money we spent, so we can set that equal to $870,000. The next one that I'm going to set up is x plus y plus z, because if we add all of the number of seats together, it'll give us the total seats, which is 23,000. Okay, and the very last one is I'm going to use there are 3 times as many seats in section B as there in section A. And the way I'm going to write that is 3x equals y. Because if you multiply section A by 3, you'll get the number of seats in y. Now I'm going to let you do this on your own, but I'm going to write down the answers. So try this on your own and then check to see if your answers are correct. So work out your system, see if you get the right solution.